problem from the joint. It's an Indian problem, I think, from the country of India, where they're preparing to be engineers, I believe. Okay, I'm not. But anyway, it's a logarithm function that deals with the domain. Okay, the acceptable inputs. Now we know the definition of the logarithm function: the base cannot be equal to 1. It wouldn't be a very interesting function otherwise. You know, the domain would just be 1 if the base was 1. And also, since the log function is the inverse of the exponential function, we need y, the input argument, to be greater than 0. Okay. Now, again, we're trying to find the domain of this. This is kind of interesting because there's no numbers in sight. You have a variable base and a variable argument. All right. Now, from above, we know from this, just this definition, without even knowing anything about the exponents or anything, we know that x squared minus x plus 1 can't equal to 1. And so that would be the same thing as saying x times x minus 1 is not equal to 0. All right, again, then that's clear. You subtract 1 from both sides and not equal to 0. In the United States, a lot of people will solve this problem and not write down the not equal, which I think is confusing. All right, but so in other words, we see quickly that x equals 0. X cannot equal to 0. I almost made the same mistake. X cannot equal to 0. And x cannot equal to 1. And again, I don't think it's taught the right way in the U.S. Many people, they just solve it, and then you have to say, and then we need to exclude it from the domain, which is okay, but this is a little more direct in my opinion. Okay, so it's clear that we have to exclude 0 and 1 from the domain. They cannot be elements in the domain. All right, now also we have to ensure that y is strictly greater than 0. In this case, y is played by this trinomial. Okay, that's the role y plays. And so the rest of this is, you could use like the vertex formula, I think, for this, or even the discriminant, but I just directly completed the square. I like doing that when I get a chance. Okay, and I won't go through all the details, but you take, factor out a 2, you know, and then you take half of the coefficient and then square it basically, and that takes advantage of a well-known algebraic identity. Now, what we get right here at the end is that our input argument, our variable input argument, always has to be greater than or equal to 23 over 8, and that would happen exactly when x is equal to 7 over 4, and that's clear. If x is equal to 7 over 4, this expression is as small as it can be. Okay. So that happens again, any other input here would just be adding a positive number, which would be bigger than the 2 times the 23 over 16. 2 times 23 over 16 is 23 over 8, right? So we see that since 23 over 8 is certainly greater than 0, we certainly see that 2x squared minus 7x plus 9 is greater than 0 as required. And that's for all x. And again, I'll just go and write that. This gets left out a lot in the US, but maybe all over the world. But for all x, remember the real numbers. Okay. Okay, so folks, what does all this mean? You know, it means that there's no exceptions for this rule, right? I mean, everything's fine right here. This part causes no problems, but we have to exclude 0 and 1. Now, there's more than one way to write this, but the domain, we can call it D. Let me see if I'm going to keep everything on the same screen. We'll call D for domain. So we see that the domain is equal to, using interval notation, minus infinity to 0. Okay, and then union, that stands for, these are sets. Okay, so from 0 to 1. And then that would be union 1 to infinity. A lot of people like to put or here, but these are sets. So U set theoretically means or. All right. Now I think another way to write it, which may be more common, you can just write it as the real numbers. You see, the only thing that's happening here is 0 and 1 are getting excluded, right? So you could also write the domain as D would equal to, and this is, I think, called the set or set theoretic subtraction, something like that. The real numbers, and minus is used in a set theoretic way here. It's not arithmetic. We're saying it's all real numbers excluding the set containing 1 and 0. And I think this is the way they prefer to write the answers in India. I kind of like it. This interval notation is a little cumbersome, but either one of these is a fair way to represent the domain. Okay, folks, I liked the problem quite a bit. Hope you enjoyed it.